In this video, we're going to talk about average rate of change. And to begin, we're going to look at this example. So you can see the context here is talking about a graph below shows the amount of drug in a person's body, A, so that's the amount, in milligrams, which is represented by the vertical axis. So again, this would be your A axis, and then the horizontal axis it's saying is T, so time in hours after a dose is taken, then how much or how does the amount of drug present in the body change on average between hour 2 after the dose and hour 4 after the dose? So I'm looking at, let's see, so if this is 5, this would be 4, right? And then this would be 2. So I'm interested, like, okay, here is the function value. So this would be, this point, right, would be 2, and then A of 2, which we can see is 6, right? So if you want to label that as an ordered pair 2, 6, you sure can. And then 4, I'm going to put the dot right there and call that 4 comma A of 4, which again, you could evaluate A of 4 and say it's 2. I'm writing it just like that on purpose. Okay, so, but this thing is asking for amount of change on average, right? So how do I compute an average, right? I would normally add the things up, divide by 2, right? If I had two things, right? If I had 2 points, I'd add them up, divide by 2. Okay, same sort of thing, but when we're looking at the amount of drug present changing, so what we will be doing is looking at the difference in the A value. So we would do A of 4, that's what it ended at, and then A of 2, so that would be what it began at, so that would be the amount of change, and then I would divide by the change in the time increment, right? So this is, so I'm looking at the change in the amounts, and then I need to say, okay, well, this would correspond to hour 4, that would correspond to hour 2, and then I would get a number, okay? And so in mathematics, this is how we compute what we call average rate of change, and it generalizes to a nice old formula. Okay, so if we have a function f and 2 points on the function, the average rate of change on that interval, okay, so we notice that the x1 is so whatever your point was that you began with, that would be the starting point of your interval, and then whatever you ended at would be the end of the interval, okay? And so to talk about the average rate of change, it really is, so f of x2 minus f of x1, all over x2 minus x1, it is just the slope of the line connecting the 2 points, okay? So again, if we call f of x1 y1 and f of x2 y2, we just calculate the slope between them. Oh, that's fine, okay? And then the only thing that I would say is coming back up to here, right? We can calculate this. A of 4 was 2, and then A of 2 was 6, and then 4 minus 2. And so I get negative 4 over 2, which is negative 2. And so this 2 means something in context, right? So just remember that if you're in context, you are interpreting it appropriately. So this would be the, let's see what it was asking for. The amount of drug present, amount, I'm abbreviating, of drug present in the body changes by negative 2, and then I have to use the units here. So this was milligrams per, and then the denominator unit was hours. So negative 2 milligrams per hour from hour 2 to hour 4. Okay, so just make sure to conclude in context. Okay, let's see. And then another thing, we said that the average rate of change was the same as the slope connecting the points. Well, slope of the line connecting the 2 points, well, here would be the line. Okay, so we could, if you want to kind of see, does my answer make sense with what the slope of the line is about? Well, you might have to do some estimating, but yeah, you can see at least the slope of this line is negative, right? As you go from left to right, the line is falling vertically, so that means you have a negative slope. And you could estimate it to be about -2, and in fact, if I had drawn it a little bit better, I should have gone right through that point. but I digress. So there we go. Average rate of change, slope of the line connecting the endpoints. So let's see it in a more numeric example. Okay, so here we are, we have a function determine the average rate of change from x is equal to 0 to x is equal to 3. Okay, fine. So I'm going to do average rate of change is equal to f of 3 minus f of 0 all over 3 minus 0. And just a side note, if you wanted to, you could also do it in the other order, f of 0 minus f of 3 over 0 minus 3. The big thing is to make sure that when you're doing it, your values match up. Okay, so zeros, or like your x1s match up and your x2s match up. Okay, either order doesn't matter. Okay, so now I'm just going to do some calculation here. F of 3, when I put that in, I'd have 3 minus 1 squared is 2 square, or 2, and then square that is 4. 4 minus 2 is 2, minus f of 0. Negative 1 squared is 1, minus 2 is minus 1, over 3 minus 0. Okay, numerator I get 3, denominator I get 3, so this is equal to 1. Okay, and so the way I would interpret this in general is that the average rate, so on average, from x is equal to 0 to x is equal to 3, y changes by 1 unit for every unit increase in x. Since it is slope, remember this is just delta y over delta x. So then when the denominator is 1, that's what this last part is saying. For a unit increase in x, the change in y is whatever we get. Okay, so be careful of your interpretation, and otherwise have fun with just some calculation with average rate of change.